know about geology is plate tectonics. The theory of our Earth is not made up of one piece of continuous crust. Oh no. It is made up of about 20 tectonic plates that are like puzzle pieces that all fit together on the Earth. But this isn't a puzzle where you finish it and it's done. No, the pieces... The pieces are constantly moving. The boundaries of the plates are either moving together, moving apart, or moving side by side. So let's look at our map. Africa is its own plate, Australia is its own plate with some ocean around, North America and South America are separate, huge Pacific plate. All these plates have boundaries with each other. And that's where the action is. So let's talk about the boundaries. We have demonstrations. The first kind of boundary is convergent, coming together. In this reenactment, Kevin and I will be playing two plates with continental crust coming together, creating mountains.
Oh, I'm a mountain!
In this next reenactment, we will show more specifically how the Himalayan mountains were formed. In this reenactment, I will be playing the passive Eurasian plate, and Kevin will be the Indian plate.
I am an Indian plate! I'm over your plate! Oh, yeah!
Yes!
Yeah.
That's exactly how it happened. Oh, but there's a different kind of coming together. Subduction. Subduction leads to orogeny. As you can see, one plate is subducted underneath. This plate is more dense than this plate. It's sucked under. So in this reenactment, I will be subducting Kevin. Yes, and that's exactly how that happens too. Subduction has a lot more heat. So I think we've mastered coming together. Yes. But now we must move on to moving apart. Divergent boundary. Divergent, divergence. In this reenactment, Peter will be playing the African plate, and I will be playing the North American and South American plate. A long time ago, Africa and South America and America were next to each other. But unfortunately, they started moving apart. I don't like divergence. I don't want to get further and further from Europe. We have to heat it up. I'm sorry. I've got to get busy with Peter. Okay. So let's talk about transform faults or strike-slip faults. That's my favorite boundary because it happens a lot in California. So in this reenactment, I will be playing California, and Peter will be the Pacific plate.
Thank you.
receiving. Peter, you better turn around and make that a left lateral. Are shocked. They know all the strike slipping that has happened in this bed already. So, let's talk about strike slip faults in California. It's fun to talk about those. As you can see, there is an enormous strike slip fault running all along the west coast of California, called the San Andreas Fault. There are many other smaller faults that aid in this movement of the Pacific Plate North and the North American Plate staying relatively in place, if you will. So San Andreas is really long, Hayward Fault, Mission Fault, all these other ones help in the movement. You guys, I forgot to tell you what a fault is. Fault is a surface where tension is built up. Oh, and those rocks are just holding on to each other. And then tension releases in an earthquake. Oh. So I think we all have some faults in us. So now, to make this more theatrical, let's do a scene. Yeah.